And there's a couple of things. So again, we're going to meet during fourth period on Friday. So fourth period at 10:46. We're going to use the period 4 link to get in here. And then, because I want to show you something new. I know some of us are doubled up in Algebra 2, and that's all well and good. But what I want to do is I want to start the unit circle and give you guys a little insight to the unit circle, because you're going to be revisiting that in pre-calculus for those of you who go on. So that's what's going to happen in the next few days. But the last week of school, you guys are going to, I'm going to have you write a reflection paper. That's going to be your last thing that you're going to do, is writing a reflection paper. And on the reflection paper, I will give you like things to follow, guidelines, like what are some things you like that we did do? What are some topics we did? What are some projects we did? You know, what didn't you like? You know, what concepts might have gave you a hard time? And then the M or the I you get on it is based on the amount of effort you put into that reflection piece, okay? So it's gonna be, you guys are gonna take the time to reflect on all the things that you're doing, and then we'll just kind of take it from there, okay? And I should have that out by next Tuesday, but it won't be due until like sometime in like June. Let me look at my calendar, because we have less than 3 weeks of school. Did you guys know that?
Yeah.
We have less than 3 weeks of school. Isn't that unbelievable?
It's Tishwa.
What?
Is the reflection about the online school or like both?
Oh, it's going to be both. You're going to talk about the pre and post kind of thing, along with anything we learned prior to. I'll make sure it's all outlined, but it's going to cover everything, because I do want your insight. I want to know what, you know, struggles you had while you were in school versus while you're out of school, like that kind of thing. So I just want you to, I want you to do a little bit of sharing with me. And like I said, the M or the I is going to be solely based on the amount of effort that you put in. So I will say that this thing will probably be due on, I don't know, like I'll say like June 10th or June 11th. That's when.
That's almost my birthday.
What'd you say?
My birthday's June 9th.
Oh, how nice. Well, maybe we'll have a birthday party. Maybe we'll do, everybody will like have a cupcake or something. Okay. Well, did you know today's Karia's birthday, everybody? Yeah. Yeah, Karia. Woo! Happy birthday, sister. Eat lots of cake and enjoy. Hoo-hoo! All right. So here's what I want to do. I want to show you something cool. We know how to find the areas of what kinds of things? Oh, don't all answer at once. Take those microphones off. What do you know how to find the area of?
Circles.
Circles. What else?
Cubes.
Well, that's a volume. What do you know how to find the area of? You know how to find the area of a circle? Go ahead. Squares. Keep going. Triangles. Keep going. Rectangles. Keep going.
Trapezoid.
Trapezoids. What else?
Parallelograms.
Parallelograms. What else?
Diamonds.
Diamonds. What else?
Polygons.
Polygons. Awesome. So we know how to find the area of lots of shapes, right? Yeah. I'm going to do a little screen share. It's time. Little screen share with Mama Schwa. Okay. What if I want to just kind of take us to like something a little more complex? Okay. So buttons. All right. So what if we had something where I asked you guys, hey, let's find the area of, let me make sure my pen's working here. It is. Awesome. Okay. Hello, little pen. This pen has been so handy dandy this whole time. What if we had something more curvaceous like this? And I said to you guys, how would you find the area of this funky looking piece? What would you want to do? Like, based on all the beautiful things that you know how to find the areas of, how would you go about finding the area of something like that? You have lots of options. Like, just think about how you would go about approaching it. Like, what would you do? Anyone? Anyone? This thing on? This thing on? Hello?
Like cut it into multiple pieces.
What would you want to do?
Like cut it into different pieces.
Go ahead, start annotating and start cutting it into different pieces. So I'm going to make a second one. So if anybody wants to annotate and draw how they would break it up, that would make me really happy. So if I want to find the area of this, how would I go about that? Start annotating. You know you can do it. If you go to the top up here, there's an annotating button for you knuckleheads that you can go ahead and do that. So I see that. Somebody do the top one. Somebody do the top one. Yeah, get in there. If we were in class, you would all have this in front of you, and I would ask you how you would break it up. So if you want to do it right in your notebooks and be prepared to hold it up, I'm okay with that too. So if you want to sketch it in your notebooks and be like, oh, here's what mine would look like, I'm totally down with that. But again, you're trying to find the area of the area of those shaded regions using the knowledge that you have, like using the tools in your toolbox. So what kind of shapes would you want to break it down into? You know, how would you go about it? Like, what would you do? And I'm just curious what some of you would come up with. Any ideas? Any takers? There's no wrong answer, by the way, because we're approximating the area. So I'm just curious as to what you knuckleheads would come up with, you know, as you're doing it. So what are some ideas that you might have? So I saw somebody went like this. That's all well and good. So in other words, who sketched this in here, by the way, the blue line? Aiden, because what you would do is you would make, so what shapes were you thinking of breaking this down into?
Like half of a circle or semicircle and like a
You would make
rectangle.
this a semicircle. What about, and this one too?
Yeah, like 2 semicircles.
Okay, and then you would do a rectangle on the bottom?
Yeah.
Okay, did anybody do anything different than that? So in other words, I'll sketch it in because it's probably easier for me to do it. Aiden, can you remove that blue line for me? Because when I go on to the next thing, it's still gonna be there, So Aiden said I would just go ahead and draw this rectangle in and then, you know, use this to estimate the semicircle. And then this over here, you would still do a semicircle? What would you do for this space over here? Because right now you have this rectangle right here, which is great. I like that. And then you said you would use a semicircle to approximate this area over here. What would you guys do for this space over here? Anybody have an idea on what you would do for the area for that space? Zach, what would you do?
Well, I see like a triangle and kind of like a rectangle.
You want to draw that in? You want to annotate it and show me what you're talking about?
Yeah, sure. How do I switch the color? It's like white for me.
Does anybody see anything else besides what Zach is seeing?
Can you like make it?
Zach, are you able to draw that in there?
Yeah, but my color's white. Oh, that's how you switch it. Yeah, I can't. My color's white, so you guys can't see it.
All right. Does anybody want to jump in? So are you saying if I were to help guide this, I'm going to change my color to pink. If I were to guide this, are you saying that this right here would be like a triangle right here?
Yeah.
So you're saying you would go ahead and find the area of this triangle and then maybe do this rectangle like that?
Yeah.
That's a great idea. Does somebody have any other ideas? Does somebody have any other ideas? This is awesome. So we would do a semicircle, we would do a rectangle, we could do a triangle and then another rectangle and then sum all of those up to get the area. What if I said you're only allowed to use rectangles? What if you're only allowed to use rectangles to find the area of this? What do you think you would do?
You could just make one big rectangle and then like subtract.
What was that, Mumbles?
You could like do one big rectangle and then like subtract the other parts from it.
So you're saying like a big rectangle, like across from here to here, like this?
Yeah.
And then subtract out, these pieces here?
Yeah.
So you're saying find the area of this, and then what shape would you guys use here, gang? What would you use? Yell it out. You would do a triangle, the same thing here. Wouldn't you do a triangle for this one, and then a triangle for that one, and then subtract that out? That's a brilliant idea. But I said that's great, and I love that. What if you're only allowed to use rectangles though? And what if it's like really, you know, like this? And you're trying to find this area here. Anyone? I'm asking you to think a little bit outside the box, and I know that, and I'm not sorry. So if you had this, right, and I said to you, what if I wanted to do 10 rectangles? What if I wanted to use 10 rectangles to approximate the area? If I were to do 10 rectangles, how would your rectangles look? Do you guys all know what I mean by that? If you were to do 10 rectangles, what would you have to know about those rectangles? What would be the things that you would want to know about? So there's one rectangle. Let's say that this is 2. See, this is 3, 4, 5, 6, 7, 8, 9. Oh, I did pretty damn good. 10, right? So if I found the area of all 10 rectangles, wouldn't that be a really good approximation to the area under the curve? Yes or no, folks?
Mm-hmm.
Yeah, it would. So that's what's really cool is, and if I wanted to get the exact area, what would I do with the number of rectangles? Well, this is 10. So in other words, if I started off with the same shape, right? And I did 2 rectangles, I would have this. This would be 2 rectangles. If I did it with 3 rectangles, right? If I'm using the same shape, 1, 2, 3. What happens as I increase the number of rectangles? As I increase the number of rectangles, what's happening, everybody?
You can't see anything.
You can't see anything? Really? Oops. Was anybody going to say anything? So, oh, I guess I accidentally stopped sharing. Okay, let me go back to this. All right, so here we are. Cancel. Can everybody see? Hello, can you all see this now?
Yeah.
Okay, so what I did over here, I'm going to minimize this so we can actually see it. So what I did over here is I said if I did 10 rectangles versus say that this is 2 rectangles and this is 3 rectangles, what happens when I increase the number of rectangles? What happens as I increase the number of rectangles in terms of trying to find the area under the curve? What's happening, gang?
It gets closer to the actual answer.
It's getting closer to the actual area. So I want to show you something. Whoops, that's not what I wanted to show you. What I want to show you is, let's say, can everybody see what I got here? Can everybody see my pretty, let me try the trapezoid. Okay, does everybody see my picture here?
Yeah.
Yeah, can you all, is this slow? Is this slow, everybody? Can you take your microphones off for a second and answer me? Is this slow or not? I'm not sure if you're understanding me or whatever.
No.
That's good.
Okay.
You can hear me or you can hear me?
Can.
Oh, okay. All right. Well, I need you to respond to me. You know how I am. I don't like to just like talk to myself. So let's say that we want to find the area under the curve. So if I follow this curve along here and I want to find the area under the curve from A to B, right now, n equals 1 represents the number of rectangles. So if we have 1 rectangle, does that do a good job of estimating the exact area under the curve? Yes or no? Does this orange rectangle give you a good approximation of like making sure this area gets covered and that area gets covered? Yes or no?
No.
No. So what you want to do then is what happens, I want to show you, is look what happens when you start to increase the number of rectangles. What's happening as you increase your number of rectangles?
You're covering more of the area.
You're covering more of the area. How many of these rectangles do you think you're going to need in order to get the exact area? How many rectangles do you think you're going to need in order to get the exact area under the curve?
A lot.
It's impossible.
What's a lot? Give me better than a lot. What do you got?
40.
Well, we could do better than 40. Keep going, because we're going to hit 40 and we're still not exact yet. See, we can still see some white space under here. How many rectangles do we need, you guys, to get the exact area under the curve?
68.
Got to go higher than
Infinite.
that. How many more do you think you need? Look, we're at 50 and I can still see a space here. How many do you think we're going to need?
75.
90.
100.
Keep going. Keep going.
80.
How many?
80.
Keep going. How many?
90.
Keep going. How many?
Infinity.
How many? I heard it. How many?
Infinity.
Infinity.
Infinitely many. You're going to need infinitely many rectangles to get the exact area under this curve. And right now we're only at 80, and then it's going to start over again. But at 80, it does a good job, but it's not the exact area yet. You actually have to do infinitely many. And do you know what that is? Do you know what that represents? You know what I'm showing you guys, by the way? You should say thank you to me. You should say, what is this, Yishwa? I'm going to stop sharing for just a second. Do you know what I'm showing you? Say what? What are you showing me?
What are you showing?
Calculus. I'm showing you calculus. That everything is done, everything is about infinite amounts in calculus. Now, the cool thing about it is everything that you learn when you guys take calculus, which is by far my favorite class to teach other than geometry, okay, is that calculus uses stuff that you already know to build concepts. So when we talk about area under the curve, so when I go back and share my screen again, and we talk about area under the curve, right over here, area under the curve has a lot of significance in physics and in calculus. And the whole thing is that it starts off with areas of rectangles that we all know how to find the areas of. Isn't that awesome? So we're using things that we know that we can use as a building block to get into deeper concepts, which I think is delicious. Okay? Now, going back to, I'm still sharing my screen, right? Hello?
Yes.
Okay. So I'm showing you this because the next thing that we're going to be doing is this your class? No. This is your class right here. Okay. So in this class, like one of the things that you're going to be working on is how to find the volume of a giant Hershey kiss, right? That's what you're trying to do. Your goal is to figure out, how do I find the volume of a giant Hershey kiss? Has anybody ever had a giant Hershey kiss like that? No? Have you ever seen one? By the way, it's solid. It is a solid piece of chocolate. So one of the things I want you guys to do is you're going to figure out how to find the volume of this Hershey's kiss. So, and it says, and you're just going to be doing a lot of reflecting on it. And again, I'm going to minimize this so I can see. So it says, how would you go about approximating the volume of a giant Hershey's kiss using what you know? If I said using what you know, what would you use to find the volume of this? What formula would you use? What does this look like it's in the shape of?
I was gonna cut it in two.
That's
Like,
fine. Okay, and then do what?
and then I would find like the volume of the two different shapes.
Well, what would you be calling those two shapes?
Would one be a cylinder? That's what I thought.
Well, how are you cutting it? Are you cutting it down the middle or are you
Oh,
cutting it across?
I was gonna cut it across.
Oh, so you said you're going to cut across this way and use the bottom half as approximating as a,
Cylinder,
and the top half you would use as a,
like a triangular prism.
okay, you could totally go with a triangular prism. Anybody go with something else? The top half of the Hershey's Kiss, what does that look like to some people?
Like a cone?
You can go with a cone. So however you do it, because again, it's an approximation. Now, if you want to get closer to the exact volume, you might want to think about how you're going to start partitioning things, okay? And you see how this thing has been partitioned. So let me just get this into my little workspace over here and go to my little picture. You guys are still following everything I'm doing?
Yeah.
Okay. Before I get into this, I want to ask you guys a question. Say, Seashore, what's your question?
What's your question?
Thank you. If I were to take this rectangle here and I'm asking you to really, really like think outside the box. If I asked you guys to take a rectangle and spin it around and round and round, what 3D shape would it form?
A cylinder.
It would be a cylinder. Because if I were to just take a line, just a line, this line here, and I were to spin it around, what would it look like? If you were to take it and just spin it, look what I'm doing. Look at my hands. If I take this thing and I spin it, imagine, because it's almost as if this is the radius right here. This is a radius. And if I take the radius and I spin it around, what am I forming? Everybody, you're forming a circle. But now that there's a little bit of a width here, now that when you spin it around, it's not just a circle, it's actually what someone just said, which is someone said it, a cylinder, exactly. So now I want to show you something here. So now by looking at this thing right here, did everybody see the red rectangle? You see the red rectangle? I'm going to assume you do. You're not listening, you're just watching. Okay. So if we were to revolve that rectangle, you can actually see that as we revolve it, what is it starting to look like? It's a little slow. Why is it so slow? It's so interesting how slow this is. Okay. What does it look like, everybody?
A cylinder?
It looks like a cylinder. So if you were to take a rectangle and spin it round and round and round, And if you were to actually take something and put it around your fingers, you would actually see that it starts to form a cylinder. Now, there is a reason why I'm talking about that, because if you go back to something like this, right, you could take your Hershey's Kiss and you can slice it all into these little pieces over here, into these little discs, i.e. cylinders. So in other words, you could go ahead and if you wanted to, you could take this piece right here, right? If I go around and his buddy, this piece right here, that's actually a cylinder. And you can find out what the volume of that is. And then you could take the next one if you want to. And then you could take the next one if you want to. So I'm just trying to enlighten you to like different ways that you can go about figuring out how to handle the Hershey Kiss. Okay? So there's a bunch of different ideas. If you want to slice it horizontally, if you want to just make it into 2 pieces, but I want you to get as close as possible. So you probably have to be the ones who have to go look up things online and whatnot, okay? On certain areas and certain dimensions of the Hershey's Kiss. Okay, so with that said, where did you guys go? Okay, so with that said, yeah, we should be good to go. And does anybody have any questions for me?
For that problem, like, are we finding we're answering, like we're finding the measurements of it and actually
Yeah, go look it up. Yeah, go look up some measurements and yeah.
so we're actually solving the problem too.
Yeah, you're actually trying to figure out what the volume of a giant Hershey's Kiss is. And it's solid, by the way. It's not a hollow piece of chocolate. It's solid. Delicious. Can you imagine? Oh my God, we could all have one giant Hershey's Kiss together. It'd be so good. Yeah. And then we're going to meet up on Friday at what time?
10:46.
10:46. Awesome. Okay. So everybody say goodbye to each other because I'm going to hang up now. I'll be around if you have questions and all that. But please work on the Hershey's Kiss problem together. I like when you guys work together. So if you want to make some time to do that, that would make me happy. But again, I love hugs and kisses. I think you guys are amazing. I will post this later on. And I will talk to you guys soon. I'll see you Friday. Love you.
Yeah.
Bye.